Hi, good day everyone. So today we will be doing May, June 2025, number 3. Alright, let's just zoom in. Alright. May, June 2025, number 3. Alright, let's just look at the question and see what they asked you. They said using a ruler, a pencil, and a pair of compasses, construct a triangle PQR such that PQ is 9, angle QRP, which means the angle P is 60, and PR is 12. So first off, let's start with the largest side, which is PR. Let's draw that first. So I have my ruler. Let's zoom in. Alright, let's zoom in. They want 12, right? So we're gonna come down and we're going to draw 12 centimeters. So from here to here is 12. Right, I'm going to put P on the side, right, because I said PR. So I'm going to put, because I have to make a 60 degrees, so I have, this is R, and this is R, and this is P. Right, we have to make a 60 degrees angle. So Q would be somewhere, P to Q would be 9. So let's just first get our compass. So what we have to do is take our compass and put it on our ruler. You know, Q is going to be somewhere on top here, and you're going to be making a 60 degrees angle. So you're going to open your protractor 9 centimeters, right? Because again, PQ is 9, right? So you open at 9, and now you're going to draw. So we're going to make a 60 degrees. I lined up with the end of P. I'm going to make that my vertex for 60. So whenever you are making a 60 degrees angle, the first things first, you're going to make an arc, draw an arc, right? Then where it intersected that first line, you're going to draw a next arc. Right, so let's just, to intersect here. Right, and we know the distance from here to here is 9. You can use your ruler to check. Yeah, so we can take our ruler to measure. Let's just zoom up to see. To measure and make sure that is 9, but it should be, because the distance from here to here is 9, because remember I opened out the compass 9 centimeters. Right, so let's just use the ruler to check it out. So when you check it out, P to here is 9, right? So you know that Q is in this location here. So let's just take off this, join P to where it intersected here. And then you would join, because it's a triangle, this is Q, and you're going to connect it to where point R is located. Right, you're going to use this and label this as Q. Excuse me. And this is how also draw. So this is 9 centimeters, and how much centimeters was this? 12. Yeah, this is 12, and this here is 60 degrees, right? And that is how your triangle should look. Yeah, right. So then, right, let's go on to the next one, which is, so this was A, right? Which was, this was trimaxial, right? Let's go here. This is part B. The diagram below shows two quadrilaterals R and S, where S is the image of R under the transformation. So S is the image of R. So this is your object, this is your image. Immediately when you look at this, you should see that the object is small and the image is larger. Immediately in your mind, you should think that this is an enlargement, right? Which should be the next question, but let's see. Describe fully the single transformation. So first off, you know that it enlarged, and we know, or should know, that when describing enlargement, you need to know a few things. So for enlargement, let's just zoom in. Shift to the side here. So for enlargement, we need to know the scale factor, which is your image over your object. You need to know your center of enlargement, which is a coordinate, and that's it. Alright, so first off, let's go here. Let's find out the center of enlargement. Now, to find the center of enlargement, you take your object and image and connect lines, and where they intersect, the line, all the object and its corresponding lines, and where these intersect would be a center of enlargement. So we're going to go need to zoom out to get everything here. So let's go with this one. Going from here to here. Then from here to here, right? Then from here, connect that to here. I'm already seeing that my center of enlargement should be here, but you can do all just to make sure. Right? So as we can see, a center enlargement, we connect our objects and image and extend the lines, and where all these lines intersect, right, would be a center of enlargement. So your center of enlargement should be, it's here, so that is x is 3, y is 7. So the center of enlargement is, let's make sure, 3 and 7. So 3, 7 would be a center of enlargement. Then you want to find your scale factor. Your scale factor, so K is your image, the length of your image. So let's say we take in this length 1, 2, that would be 2 over the corresponding length is 1 in your object, so your scale factor is 2. So with this, we know that you would say right, that object R was underwent a transformation of enlargement with a scale factor of 2 and a center of enlargement of it was 3.7 to produce image S. Something along those lines. It does not have to be exactly that, but you do have to make sure you have these two things for enlargement. Right, now let's see what part 3. Part 2 says, on the grid on page 12, draw the image of quadrilateral R when it is translated by a vector -4, 5, and name it image T. So R is going under a translation. So as we said, R is undergoing a transformation of a translation, I should say, -4, 5. So we know when they describe your translation in the form of a vector, right? The one on top is the displacement along the x-axis, and the value underneath is the displacement along the y-axis. So -4 - 5, right? So you're gonna take 1 and go, it's -4, so we're going in the negative direction along the x-axis. So it is 1, 2, 3, 4, and then it's -4, 5. So it's 5 units in a positive direction along the y-axis. 1, 2, 3, 4, 5. So the image is going to be on your y-axis 9. Right, so the image of this point is right here. Right, and we could just count down 1, 2, 3, 1, 2, 3, right? Then from here to here is 1, 2, 3. It's 3 units. 1, 2, 3. So it'll be here. 1 unit up. Or you can even check it. 1, 2, 3, 4, and then 5 units up. 1, 2, 3, 4, 5. Right, and you can keep on doing that for the rest. And you just connect it. It's going to be from here to here, then here to here, here to here, and then here to here. And they said to label it T. Right, name that image T. Now let's look at the last one. On the grid on page 12, draw the quadrilateral R when it is rotated 180 degrees about the origin. Name the image M. So to do this question, there are 2 ways to do it. You can do it the matrices method, or you can do it the manual method. The matrices method, you have to remember what is the matrix for rotation. For a rotation in 180 degrees, right? So when it is rotated 180 degrees about the origin, right, it is 0, -1, -1, 0. You take your coordinates and multiply it by this matrices, and it will give you your image. right? So when we look at this, let's look at the coordinates of R, and I'll put it in green. We know that this one here is x is 4, y is 1. This one here, x is 4, y is 4. This one here, x is 1, y is 2. And this one here, x is 1, y is 1. Right? So you're going to take each one of them and multiply it by that matrix, and that is how you would do it. So let us first do 4, 4. And you're going to have to put it in the matrix format. So it would be 4 on top, 4 at the bottom, by 0 minus 1 minus 1, 0 to give you an image. This is a 2 rows by 1 column, and this is 2 by 2. So it's not this you cannot multiply it this way. It has to be the transformation 0 minus 1 minus 1, 0 by 4, 4. This is a 2 by 2 matrix, and this is 2 rows by 1 column. We always have to make sure that these are equal to when you make sure that these are equal, then it is conformable to multiplication. So it's row by column, so it's 0 multiplied by 4 plus minus 1 multiplied by 4, and then minus 1 multiplied by 4 plus 0 multiplied by 4, so you'll get minus 4 minus 4. So the image of this is minus 4 minus 4. Alright, so let us do that in blue. Minus 4 minus 4. Alright, that's the image for this. And then the image for this one, 4, 1, should be minus 4 minus 1 minus 4 minus 1, which would be this. This one here would be minus 1 minus 1. This one here would be minus 1 minus 2. Right, and that is how your transformation, when it rotates 180 degrees, would or should look. Right? Hold on, let's do this properly. And they said to call that image M. Right, and that is how you would do this transformation. Right, and also if you notice, what happened is that we took the coordinates and multiplied by negative 1. Right? Each of the coordinates, when there's a rotation of when there's a rotation of 180 degrees. Now, when there's a rotation of 180 degrees, doesn't matter if it is clockwise or anti-clockwise, right? Only for 180 degrees. I realize that we are taking the coordinates and multiplying it by negative 1. Right? So that is how I did it so quickly. Right, and that is how you would do May, June 2025 number 3.